Hello, thank you for your interest in the street lighting calculator. In this video tutorial, you will learn how to use the calculator in just 7 easy steps. But before we begin, notice that there are 3 different worksheets: Basics, Input and Results, and General Assumptions. We will review each, but mostly we will work in the second, Input and Results. Right now, we are on the first worksheet, Basics, which offers information about the calculator, like its affiliation with the European Commission Green Public Procurement 2020 project, and the organizational partners that have helped produce it. Here we have also included an explanation that this tool calculates energy consumption and greenhouse gas emissions generated by the illumination of streetlights, but it does not include the energy necessary to run the lighting infrastructure, like, for example, the control, nor does it include emissions generated from infrastructure. Please bear in mind when using the calculator that the decimal separator is a comma, not a point. Now let's begin the tutorial in which we will use the calculator to show us the energy and greenhouse gas emissions savings of using low carbon versus standard street lighting. On this worksheet, we will enter information for a benchmark, whether our current system in use or a tender for a less energy efficient option, and also for the low carbon solution we may be considering or measuring. First, we select the country where our street lighting will be in use in order to determine the amount of greenhouse gas emissions they will generate, and we will select Croatia for this example. This step is important because each country has its own average electricity mix, and therefore similar devices used in different nations generate differing amounts of greenhouse gas emissions per kilowatt hour. Note that on the General Assumptions worksheet, you can review the assumed value of emissions per kilowatt hour for the countries listed. If you believe that you have a more accurate value for your country, you can adjust the value on this worksheet, and the calculator will adjust its output accordingly. For now, we will not change anything, and we will continue with our inputs. Next, we enter the lifetime for which the device will be used in years. For our example, we enter 25 years, which is a standard lifetime for streetlights. Once we are satisfied with the figures in the upper part of the worksheet, we can start to include the figures in the center with details of our purchase order and how we will use the devices. Note that we can only change values in the orange cells. Here we have the option to enter the type of light fixtures included in the benchmark and the low carbon solution, as well as the name of the manufacturer. This information might be useful for you to track, but it is not necessary for the operation of the calculator. Then we must enter the number of lights specified in our tender. For this example, we enter 500. Next, we enter the power per lamp in watts. This information should be available to you in your current contract, or you can use figures for a conventional solution offered on the market, and your new tender for a low-carbon solution. In this example, we are using values for a benchmark and a low-carbon solution provided by a municipality in Croatia and published as Procuring LED Street Lighting Solutions on our website. Some streetlights are dimmable, which means they have 2 different operating levels of power. We have provided fields for you to enter this data if it is available to you. Using our example from Croatia, we enter just one level of 120 watts for the benchmark, and we enter 2 levels for the low carbon solution, 103 watts for level 1 and 50 watts for level 2. Then we must enter the number of lamps per fixture, and in our example, we enter 1 for both models. Once we have entered all of this information, we can see that the installed power base in watts is provided for us by the calculator. It is the product of number of light fixtures multiplied by power per lamp and then by lamps per light fixture. Finally, we now enter the operating time in hours per year for our two street lighting options. Where we have two power levels present due to dimmable light fixtures, we split the total hours per year between the two. For our example, we enter 4,000 hours per year in level 1 for the benchmark, and for our low carbon solution we enter 2,000 hours per year each in levels 1 and 2. Now we have entered all necessary information, and we can review the results for energy and emission savings. We see the benchmark consumes 240,000 kilowatt hours per year, while the low carbon solution requires just 153,000. In this case, using the low carbon solution results in savings of 87,000 kilowatt hours per year. In terms of resources, the benchmark would require 21 tons of oil equivalents per year, while the low-carbon solution would require just 13 tons. That's a 36% reduction in energy. Over the course of a 25-year lifetime, the low-carbon solution would reduce consumption by 187 tons of oil equivalents. This means that, of course, low-carbon street lighting results in far fewer emissions than the less energy-efficient options. The low-carbon solution avoids 27 tons of greenhouse gas emissions per year and more than 600 tons over the course of a 25-year lifetime. So now you know how much energy your municipality can save if it uses low carbon versus standard street lighting, and also how much greenhouse gas emissions can be avoided too. We hope that you will find the calculator easy to work with. Notice that on our website there are more calculators for the product groups ICT, vehicles, and energy that might be useful to you. Each calculator has an accompanying tutorial on how to use it. Our website also offers a multitude of studies showcasing energy and emission savings across a variety of sectors and locations, which you can find under Best Practice Examples. If you have questions about or comments on the calculator, you can also find our contact information on our website. Goodbye and good luck.